Okay.
Okay, so also I gotta say good on you for figuring this out. I feel like because for you, I went very quickly, so I was a bit afraid that I went too quickly. But you figured
Okay.
it out, so congrats. It's not
Thank you.
obvious. Uh, it's a series of realizations you have to make. First, you need the realization. You need a structure in order to um do more than one thing, right? Because if you're trying to do something that's arbitrarily large, you need to contain more than one thing, so you need a structure. Uh, Second thing you need to realize is that that structure needs to be at least two things. The third thing you realize is that the second thing in the structure can't be another number because otherwise you just
Mm.
have two numbers. So you need to be something that could hold more numbers. Oh, so itself. The second thing of the structure is itself, another list. The next realization is that you need to have the empty list. Otherwise, you can't even create an example. So you were able to face all these realizations last time, and that's amazing. Let's before we move on with num list, I am going to show you something a little bit different. It's the idea of nested structures. So, okay. So far we saw that we can actually data definitions can refer to other data definitions. For example, let's go to what's an example? Uh, okay, I guess the num list is an example. Line 208. This num list refers to number, right? It's referring to another data definition.
Yeah.
What's very interesting is that this data definition doesn't have to be uh, a primitive value. It doesn't just have to be a number. It could be another data definition that we create. So I'm going to create an example. So I do game development. So this is a game development example. So let's say I have a ball data, okay?
Okay.
And this ball is going to be a structure. Oh, wait, I'm skipping the design recipe for now because I want to get straight to the point.
Yeah, okay.
Uh, so let's say it's yeah, okay, let's do this. I'm going to call it a ball. It's going to have two things. It has a position, and then it's going to have a velocity. So yeah, this is like very, very standard in game development. That thing, that's it, right?
Okay.
Yeah. So and then I define a position. I'm just going to do it all in one line. It's easier. So position has an X, Y. Do you play video games?
Yeah.
Okay, so this makes sense. You play like, oh, okay, what kind of games do you play? Just so I know that you know what I'm talking about.
Like, I don't know, Minecraft, CS.
Okay. Okay, so you know what I'm talking about. So those games they have physics, right? You have a
Yeah.
position in
Like,
the world. Like Minecraft, if you know there's a key you can press in Minecraft to show you like where you are in the world, like your coordinates.
yeah.
Yeah, okay. So that's the idea, right? You have a position in the world and then how fast you're moving. Very standard. Usually physics engines deal with this. Anyway, so here we have an example where we have one data definition ball that refers to another one, which is line 205. Actually, you know what? I'm gonna actually do this. A ball is a ball. Oh wait, the I made a mistake on line 203. The second thing should be
Yeah,
velocity.
yeah. I was trying to tell you that, but
So you're trying to tell me that by saying nothing. Okay, thank you, man.
yeah, yeah.
No, it's okay. I know I was talking
I was
about.
like thinking about it, but I didn't mean to correct you.
Yeah, okay, no, you didn't want to interrupt my stream of thought. Okay, I appreciate that. But
Yeah.
it's okay. Next time you can just interrupt. If it's like five words for you to say it, just say it.
Okay.
Yeah. S- so yeah, I'm gonna skip the interpretation, but you might see something like this, right? A ball is a ball. And then we have a
Okay.
data definition that we're referring to. For another tangent, notice how this position and velocity, they're like basically the same. The only difference is their name, right?
Right.
So
Yeah.
you might say, and this is very, again, very standard in game development, you might define a common structure. Let's say like vector 2D, okay? I'm going to say
Okay.
V2D. That's a number and number. And then you want, uh, That's a fact. I'm just gonna call it. So yeah, notice how the type vector 2D can be different from the name of the structure itself. So the name of the structure is just V2D because it's easier for me to type.
Okay.
Uh, yeah, so you may choose to do this. There are pros and cons to doing this. I'm not gonna get into it because I feel like it won't really help you for competitive programming, but it will help you with regular programming. But if you're curious, we can go over it next time. But you may choose to do this instead, where you use vector 2D instead of specifying a more specific data definition. In the case of physics, it makes sense to do vector 2D because you're going to use common operations for both positions and velocity. For example, you want to be able to add two vectors together, right? I
Oh,
don't
so like we don't have to like write it twice, yeah?
exactly.
For
So in this
okay.
case, we did the pros and cons. The pro here is that we only have to write one set of functions for operating on pairs of numbers. So
Hmm.
we should stick
Okay.
to using one data definition. Are you familiar with linear algebra?
I don't think so. Like
Okay, that's
I
okay.
don't recognize the name in English, but can I
Okay.
type it like Google it
Yeah,
like
sure. Yeah,
real
linear
quick?
algebra.
Yeah.
Yeah. Are you Googling it?
Yeah, I don't think so. No, I
Okay.
don't know
All
it.
good. So you don't have to know
Okay.
about it. It's okay. Pretend I said nothing. But basically, linear algebra is algebra, but with you have vectors. What I'm talking about here. Uh,
Okay.
but there's also vector 3D, just vector 4D. There's like multi-dimensional vectors. But anyway, you don't have to know this. I'm just letting you know. I don't know if you plan to study more mathematics in the future. But yeah,
Mm,
actually,
probably I will, yeah.
if you do competitive programming, you might have to learn linear algebra. I'm not sure because it's mathematics.
Yeah, I maybe.
Yeah, maybe. So yeah, okay. So you might have to learn it. It's essentially a way for you to do perform mathematics on groups of numbers at a time. That's an oversimplification, but that's basically what it is.
Okay.
Anyway, the reason anyway, so I'm going to use vector 2D here just to simplify an example. Let's say so I'm going to create our template. I'm going to do it for you just because I know I have a feeling that you already know how to do this, so I'm just going to speed things up. So ball template is going to take in a ball. I'm just going to call it B. Um, so do you remember the template for structured definitions?
Uh, like we need to uh, have as many cases as there are like definitions.
Yes. Oh, well, that's more specific to
Okay.
the enumeration. You're thinking of the
Yeah,
one-off, right?
okay, yeah.
Scroll a little bit, look at the iTunes example. Do you see it's
Mm,
ITS template?
yeah, okay.
So it's not as many cases. The idea is right, but it's not cases, it's parts, as many parts. So you
Parts,
want to list all
okay,
the
okay.
parts. Yeah, because structure is about combining different parts together,
Yeah,
right?
okay.
So I do B dot position, B dot velo. Do you know why I do the dot dot dots?
Uh, like there might be something there, yeah?
Yes, yeah.
Yeah, okay.
Okay. So are we done here? Is the template done?
Uh, yeah, I think so.
Okay.
That's
So spoilers, there is something where we should add, but I'll get to that in a moment. So I'm gonna do a vector template here.
okay.
Um, so again, v dot x, v dot y. This is nothing special. I'm gonna do something
Mm,
interesting now. So I'm gonna create a function that is going to move ball. Okay, moves the ball.
okay,
Uh, just gonna call it move ball. You're going to take in a ball B. So in fact, here normally, um, you apply the I ask you to write the function header and whatnot, and sometimes I do that. Oh yeah, so moving a ball just produces a new ball. But I'm gonna just use the template actually. So I'm gonna copy and paste the template. I'm just gonna paste it in, and I'm gonna replace anything that should be replaced. Move ball. Uh, Next I'm gonna do the test cases. But okay, pretend I did the test cases. For you, I want to move a little bit quicker, so I'm not gonna do it. But pretend I did, okay?
okay.
P dot position, and how do you move a ball given a position and velocity?
Like increment the like it depends what direction we want to move the ball
So
in.
velocity, so in physics, velocity has direction incorporated into it.
Okay,
Yeah.
okay. So like velocity increases, yeah?
For example, yeah, if velocity is positive, then you'll be going faster. Yeah. You'll be moving in the
Yeah.
same direction.
Okay, okay.
Yeah. So how do we move a ball given a position and velocity?
Mm. What? Uh,
So yeah, so here's a hint, and this is actually part of the
okay.
process. So the reason why you feel stuck is because you're looking at position and you're looking at velocity, but you're not thinking about what they are, right?
Right,
So
yeah.
part of what we have to do now is we have to think about, oh, what is a position? What is a velocity? So what we can do is we can break them down to their parts. So let's say like velocity dot x and b dot velocity dot y. Okay, now what should we do?
Mm,
Oh wait, I should actually ask you, what is velocity?
yeah, that is like the most important question for me.
Yeah,
Uh,
so what is it?
what is velocity?
Yeah.
Uh, it's
Okay.
not like speed, yeah?
It is speed with direction.
Speed with direction, okay.
Speed with direction, yeah.
So why do we need like X and Y,
Because you might be moving in two axes. Like for example, Minecraft, there's three axes, right? You could jump, you could move left,
right?
or you could
Yeah.
move forward. In our case, we can only move left and let's say like Mario, you can only move left and right or jump up and down. So there's two axes, so there's X and Y.
Okay.
Yeah.
Oh, okay.
Oh yeah, but let me tell you this, velocity is change in position. It's also can be defined
Okay.
as velocity is speed plus direction. How fast you're moving and where you're going combined.
Okay.
Yeah. So given this, how what do we do with all the X's and Y's?
Uh, like we would create like okay, we need to return a ball, yeah?
Yes.
Okay. So I would write it down.
Oh, so like you mean like this?
Yeah,
Do
like
this first.
this.
Oh, clever. Okay, okay. I'll talk about this later, but good. Keep going.
Okay. Mm, and in here I would like hmm maybe if we have like
Mhm.
vector 2D we would use that.
Ah,
It
okay.
it would be easier.
Sure. Okay, how would we use a vector 2D?
Can I write it down?
Yes,
Like
yes, please.
uh, okay, it would be like uh, don't we need to like uh, oh sorry uh, I might make a typo, but
Yeah, it's okay. Good, good. Yeah, that's right. And
okay,
close
and
closing parentheses.
yeah,
But I think if you run it,
yeah,
that'll
but we need another like it would be
mm-hmm. S-
mm,
You may assume the velocity remains the same.
Okay.
Yeah, I should have said that.
Okay.
Very good. So yeah, that's right. If you run it, I believe it will tell you that there's something. Oh, doesn't.
Oh, that's great news.
If you, I'll tell you what the problem is though. So line
Okay.
222, C is you wrote b dot position dot x, right?
Right.
But then you wrote ball dot velocity dot x.
Oh, okay. Yeah.
Okay,
Yeah,
okay,
right.
so you do know, yeah, perfect. Yeah, we have to refer to the parameter because that's the
Yeah,
thing we're
yeah, yeah,
breaking down.
yeah. Yeah,
Very
yeah.
good. Okay. Now I think that is correct. But notice how this function looks kind of complicated.
Hmm. Yeah.
Okay, so what I want to talk about now is the idea of I don't know what's the word for it, but okay, let's start small. I want you to go look at the ball template. It looks very simple, right? You just have position and velocity. But then if we look
Right.
at move
Yeah.
ball, it looks like wow, it's kind of a lot going on here. So let me
Hmm.
ask you, where did that complexity come from?
Uh, it came from that we used like another class, another data as uh, part of ball. Yeah. Like we
Yes,
didn't use a number or something, but instead we use like a vector 2D.
yes, exactly. And
Yeah.
notice how the template on line 208, we only see position and velocity, but we don't see x and y. But in line 222, we see x and y.
Yeah.
What we have done is we have combined the template of 208 and 216.
Oh,
Okay?
yeah, right. I see it now.
Okay, so here's a rule of thumb. If the data definition cannot see the field, the function also should not see the field. So in our case, x and y, ball data definition, if you look at 203, ball data definition has no concept of x and y. It doesn't understand x and y. It only understands vectors. Okay? But line
Yeah.
22, we broke that rule. Line 22 is dealing with x and y's. Okay?
Okay.
So, uh, yeah, we shouldn't do that. At least, like, for our purposes, we shouldn't do that. Sometimes in life, you have to break the rules to get things done fast, but that's a different story. But for now, let's not do that. What this points out too is that there's something missing in our template, and there's something missing to how we should solve this instead. What's the alternative to not using dot x and dot y in line 222?
What can you use something instead?
Yeah, like if line 22 is not allowed to do dot x and dot y, what should we be doing instead?
Hmm. Yeah, like we could write down another function to
Okay.
add to
Well,
vectors.
perfect. Okay, can you write that down for me? And can you fix the
Uh,
original function?
where?
Yeah, yeah, can you write that function?
Yeah, yeah, but where? What line?
Oh, let's say line 224.
Yeah. Okay. So it would be let's take two vectors and might and mm, yeah,
Great.
I think that's it. Yeah.
Yeah, that looks pretty good. Normally I ask you to write tests, but let's just skip the test and let's fix line 222 using this function.
Uh, right.
Yeah.
So uh, the second thing doesn't change. Yeah.
Yeah. Because we're doing nothing with it, right?
Yeah.
Okay.
Uh, that's it.
So
Yeah.
do you see that? It feels a lot better, right?
Yeah.
Okay. And imagine like in if you're making a game, let's say we're making Minecraft, there's cows, there's sheep, there's pigs.
Mhm.
We're gonna be adding vectors all the time. It'd be nicer if
Yeah.
we had an add vector function, right? Okay. Uh so I'm going to talk about the template again. So the goal of the template is to be able to tell us how to write like the shape of the function, like what to fill in. And clearly our template was lacking because that wasn't obvious. So what
Mhm.
wasn't obvious is that we actually should be um the word is delegating to a function. Like position is a vector 2D. We might be calling a vector 2D function on position, right?
Okay.
So I'm going to update the template and I'm going to say, so I'm on line 208 now. I'm going to do this. You see that?
Yeah.
So it's to
Okay.
communicate the idea that we have a position that is a vector 2D and we might be operating on it. And so we might have to refer to a function that uses the vector 2D template. Okay.
Okay.
Are we done here? Line 208?
Now we need to do the same thing with velocity.
Yes. Okay, I know all this sounds unrelated to the list, but I assure you it's very important. It's a very important idea.
Okay.
So the idea here is that when you're dealing with a data definition that has been defined, you need to use a template corresponding to that data definition. Okay?
Okay.
Now, if so on line 212, we have X and Y, which are just numbers. That's just a number. We can't do anything with it. So that's it. Like line 216 is done. We don't have to call another template. Okay?
Okay.
Okay, yeah, I think that's all I have to say on this matter. I think we can return to lists now. Do you have any questions about any of this?
No, it wasn't easy, but it was okay. It was
It's okay.
like
All right.
meat.
So this is not going to help you directly in competitive programming. Because what this is saying is I want you, like this is saying to write more functions essentially. But in competitive programming, sometimes you don't want to do that because it wastes time. And also it splits your code up into multiple places when you want them in one screen.
Yeah.
Um, but this will help you think about how different data connect to each other. Like you have a deeper understanding of how things relate to each other.
Okay.
Yeah.
Yeah.
And this we're going to go back to the list now. So let's scroll down and go back to list and we're going to apply this idea. My next goal for oh, actually, I just realized something. So okay, we're going to go back to using the design recipe. Just now I skipped the design recipe because I wanted to go through that quickly. Um, so we have an interpretation with the data representation. We have an example, but one thing about what is something about examples that we had to do with itemization? So itemization is when you have one of many choices.
Yeah.
What did I say about creating examples for that?
We need to have like edge cases.
Okay, what's an edge case in this case?
Hmm. Okay, like one number
Okay, let's do one
would
number.
be, yeah.
Yep.
Uh, do I write it down? Or
Yes, yeah. Like line
okay, okay,
239.
okay. What do I call it? One number?
Yeah,
Okay.
sure. Okay, are there any other cases that we should have an example of?
Like no numbers.
No numbers, good. Let's write that.
Yeah.
Okay, so a good habit to have in the future is always start with the simplest example and gradually increase in complexity.
Oh, okay.
So yeah, you start with three, then you went to one, then you went to zero, but next time start with zero, then one, and then three.
Okay.
Is that how we create an empty? What's an empty list?
Is that not, oh, wait. Oh, I can just call it like
Empty.
this. Yeah.
Yes.
Okay, sorry.
Okay. No, no, all good. And okay, this is fine for now. I want to so naming names are just arbitrary. Names could be anything. You could call the list Marvin, but I would
Okay.
say there are better names, but we're going to revisit this idea later. Okay, next
Yeah.
I want you to write the template for this data definition.
Uh, okay. Like, okay. Uh, Let's take on this. Uh, oh, it's kind of hard because we have like we don't know how many numbers do we have.
Okay, let's start simple. Remember, what is numlist fundamentally? It's an itemization, right? It's one of many choices. What's the template for breaking down one of many choices?
Mm, one of many choices, like cases, yeah?
Yes, cases, yeah.
Okay. What was the it was like this? Or
Honestly, I don't remember, but if you scroll up, I think you can find an
yeah, yeah.
example.
Okay.
It's like line 73, for example.
Okay, okay. So it's like it's different. Okay. Mm, okay. And uh is it like I might I have to look at okay, okay. It's like this.
Hmm.
Uh and something, yeah.
Yeah, and something.
And hmm, it's like this.
The num list here in this case is referring to the
Yeah.
type on line 237. So the names must match. There needs to be a hyphen. Num hyphen
Okay,
list.
okay.
Yeah, so line 247 and line 237
Yeah,
are
yeah.
mirrored. Okay. Oh, okay. So
Yeah.
this next part, I don't think we covered this actually. So I think I have to explain this. Actually, wait, give me one sec. I need to look up the syntax. So notice how we have a structured thing inside like a,
22, yeah, yeah. And for cases.
oh yeah. Okay, yeah, give me one second.
Yeah, of course.
Hmm, Just looking up the syntax. Yeah, okay, that's what I thought. Okay, so you don't know this, so I'm going to show it to you. Um, Whenever you're using the cases expression, so we call that line 245 to line 248 cases expression. Whenever you have one of it is structured, you can actually put parentheses after the num list and break it down like this. Okay?
Okay, okay.
So this is part of the syntax. You don't have to call it a numRest. You can call it N and R. In my case, I'm just gonna call it numRest. Just keep it simple
Okay,
and make it
okay.
the same as line 237. Um, okay. So I gave you, yeah, so this one I write for you because you didn't know this. Okay. We have a structured definition, we have structured data definition inside our, sorry, let me say that again. We have structured data inside our num list. So one of our cases, we break it down. Notice how line 236, line 237 mirrors line 246, line 247. They look the same, right?
Yeah, yeah,
Okay,
okay. So,
keep
okay.
going.
We need to mirror it like everything eventually.
Exactly.
Yeah.
So line 247, we have a num and a rest. Are we done here?
Are we not? Like,
So here we now apply the template for structured data. What was the template for structured data?
we need to what?
Like if you look at the vector 2D template and the ball template, what do those templates look like?
Okay, so is that it would be like uh
Oh, okay, yeah, keep going.
like this?
Yes. Are we done here?
Okay. Are we not? Like,
So let's review the types of each field. So num is a number.
Mm,
Can we do anything with number?
mm, no, like,
Okay. Okay.
what do you mean?
Okay, it's okay. I'm gonna
Okay.
leave, like for example, like the vector 2D x and y, we couldn't do anything with it, right? So we left it at
Yeah,
that.
okay. Okay.
Okay, no, no, let's do it now. Okay, how about rest? Can we do anything with rest? What is rest?
Like, rest can be, okay, rest is anomalous, yeah?
A num list. It's referring to another data definition. So what do we do when a thing in our template is referring to another data definition?
Uh, like this, and we need to do like this, so on. So, like,
Let's go back to the ball template. In the ball template, we
okay.
had the ball has a position and velocity, right, which are both vector 2Ds. What do we do with the vector 2D?
Oh, okay. So it would be like,
What is
that's
num list?
correct.
Like, what's the capital NL num list? What is that?
Like the data.
Okay. But if you refer to the ball template, are we using the data in any way?
Oh, we are using like templates.
Yes. We
What?
might not
Okay.
we might not be creating a num list that we could be doing anything. So how do we signify anything? We refer to the template. The template is a stand-in for saying we could do anything that has to do with num lists. Ah, now that's right. This is the template.
Okay.
Okay, one thing I want to add, so this is not wrong. However, notice how in your template you're breaking down num lists into with numlist.num, numlist.rest.
Yeah.
But notice how at the start of line 247, part of the syntax of cases is that it does the breaking down for you.
Okay.
You see numlist opening parentheses num comma rest. You see that before the left
Yeah.
arrow?
Yeah.
So that's breaking it down for you already. So we can actually do this. I'm going to delete a numlist dot and just do num and rest.
Oh, okay. Okay.
And the only reason why we can do this is because cases breaks it down for us. And
Okay.
we're just
Okay.
using the pieces. Yeah.
It
But
makes
what you
sense,
did just
yeah.
now was right also. It will also work. Uh, yeah. So anyway, like this is like I think it's inspired by OCaml. Do you know OCaml?
What? No, I don't
Okay,
think
okay. It's
so.
another programming language. It's okay. Pretend I said nothing. But some programming languages they have things that look like this. Um, C++. I don't think C++ has this. Not that I'm aware. All right. So now that this is the numbers template. One thing I would also like to add is you should add a signature like this, numbers to question mark, just
Okay.
to make it more complete. Notice how there's no purpose statement because it's a template. There's no purpose.
Yeah.
Okay, so now we are done with the data definition design recipe. Next, I'm going to give you some exercises on dealing with lists.
Okay.
Um, I do want to say a few things first, actually, before we move on. First, I want you to notice a few things. First, notice that this, have you heard the word linked list before?
Linked list.
Yeah, have you
Uh,
heard of it?
yeah, like what? Like the element points to another element, yeah?
Yeah, yeah, something like that.
Okay, yeah.
Uh, this is a linked list, essentially.
Okay.
You have a number and then
Okay.
it points to a rest, which is also itself. In C++,
Yeah.
you will use pointers for this.
Okay,
Uh,
yeah.
yeah, this is actually a linked list. The second thing I want you to notice, oh yeah, you don't have to know linked list, but like I think in competitive programming, you need to know data structures. Linked list is one of them.
Okay.
Second thing is this is the simplest possible arbitrarily large data definition. It's this, I do not believe you can go simpler than this.
Yeah.
So here's a claim, okay? I want you to argue whether or not it's true or false. And arbitrarily arbitrarily large. When I say arbitrarily large, does that make sense?
Yeah, yeah,
Okay. S- Self-references. Okay, so let me explain self-references. Self-references means you're referring to yourself. So we say the numList is a self-referential data definition because numList is defined by numList. Does that make sense?
yeah.
It
Okay.
refers to itself.
Yeah,
So
yeah,
my claim is that an arbitrarily large collection of information necessarily require, oh, sorry, let me say data. Data is more accurate. Large collection of data necessarily requires self-references. True or false?
yeah. I would say it's true
What do you say is true?
because how would how would we do like without self references? How to
Okay.
like the another another items in the collection must be like the same type as the collection, yeah.
Hmm. Okay, that's a good answer. I'm going to provide a counter argument. Do you know
Okay.
in C++, do you know malloc?
Was no.
Oh, never mind. Have you wrote new in C++, like write the word new?
Oh yeah, it's like yeah, I know that like uh how to say that in English? Uh,
Like for example, like
like
if I'm
a
writing C++, yeah.
okay, okay.
Like let's say like I have a vector 2D, I write like new vector. Oh wait, sorry. Have you seen this before?
Yeah, yeah.
Like the new keyword. Do you know what the new is
Yeah.
doing?
It's like reserving like space for
Yes, reserving
the
space.
yeah.
Now, what if I do like something like, oh, you know what? Okay, okay, I'm not gonna get into this right now because maybe I'll talk about this in the future when we talk about memory if we ever do that. Okay, I think that might
Okay.
be too advanced for us. Yeah, it's too much of a tangent. So we'll revisit this in the future. So for now, it seems like yes, right? You need self-references. Okay, so claim of Earth is pretty true. There are some caveats, but it's pretty true. Let's just say that.
Pretty true. Okay,
Pretty
okay.
true.
Pretty true.
N- Next thing I want you to notice is self-referential definitions don't make sense in natural languages. For example, let's say a table is a table. I ask you, what's a table? And you say, oh, a table is a table. You wouldn't be happy with me, right?
Yeah.
But
Okay.
however, they make sense. However, self-referential data definitions in programming make sense. Why? Yeah, let me ask you, why does it make sense here?
Why does it like okay.
So yeah, why does it make sense?
Because we need to like have the base case so we
Okay.
don't go like infinitely long.
Okay. And to be able to create examples in the first place, right?
All right. Yeah.
Yes. So data definitions are intended to generate examples of data that belong to the class that is being defined. That's actually what data definitions really are in the end of the day. Like data definitions, they're like a human construct. Like that's just something that exists in our brain, right? But the
Right.
examples,
Yeah.
like list of one or whatever, that's the thing that actually exists. Our goal is to make the
Okay.
things that exist. So if we can do that, it works, right?
Yeah.
And as you said, the base case is what allows us to be able to do that. Okay, so that's the next observation. I think that Yeah, I think that's all. All right, so I'm going to give you some exercises now, and I want you to follow the
Okay.
design recipe. What's the design recipe? So signature, purpose statement, paste in the template, write the task, and then fill in the body. So my first task for you is uh sum a list of numbers.
Okay. Um, okay, so I write it down, yeah. Uh,
Yes. So what's the first step of the design
okay.
recipe?
Design recipe.
Yep.
What was like the first step? Uh,
Yeah, so I'm asking you, what's the first step?
hmm, ah, yeah, data representation.
Okay.
Okay. Mm, so we would like our function will take a list, yeah,
Yeah.
and output a number, yeah.
Good. Okay, one thing about the name list, we refer to the name on line 235, right? Num list. Like that's important.
Okay.
Yeah.
So like this, yeah.
Yeah.
Okay. Uh, uh, so uh, is that correct?
Yeah, very good.
Okay. Mm, okay. And we need to write cases, yeah, every like examples, yeah.
Yes.
Uh, oh, okay. Mm, okay, so I would like it maybe uh, on this. Mm, of like the first one would be like the edge case where we have like empty
Sure.
list, yeah.
Makes sense.
Uh, don't we have like actually mm, made like examples for this? Yeah, we have.
So yeah, let's use them.
Yeah. Uh, what was the syntax for? Okay, is okay. Is zero,
Okay.
yeah.
Okay.
Some list of okay, that is uh okay. It's like hmm, how to write it down? Can I just do like this or? Yeah,
Oh, yeah. It's a number,
actually.
right? Yeah.
Yeah, it's okay. What is it like 6?
Yeah. Okay. Nice. What's
Okay.
next?
Yeah, we need to like write cases, of course.
So I advise just pasting in a template.
Yeah, okay,
Yeah.
sorry.
So for learning, I recommend just pasting in a template, but in the future, you do this so quickly you can write it all in one shot.
Okay, okay,
The idea here is that your brain already has you're already thinking in terms of the data that's passed in and knowing how to operate on it. The template is a shortcut
okay,
to make that happen. Okay,
okay.
great. So what do we do now?
Should be like 0.
Ah, why zero?
Mm, because it's empty, yeah? And
Okay.
the last element must be like 0 to not mess up everything.
Ah, okay, very good, very good. Okay, keep going.
Okay. Oh, so it'd be like,
Wait, don't delete the dot dot dot. Wait. Go back, go back.
sorry,
Yeah,
sorry, sorry.
yeah, work with this. It's important why you want to. I say this because I'm going to explain something in a moment.
Okay. Oh, okay, it makes sense. Uh, of rest.
Okay, let's run it. Oh,
Okay. Sorry.
all good.
I must, yeah.
Yeah, so yeah, this is why I recommend to always paste in the template in its entirety so that it's
Okay.
consistent. I think that's still missing a few characters, right? The parameter is endless, but everything else is referring it to it with a different name.
Uh, am I really? Yeah. Sorry. Numbness? What is, and it's, yeah.
Okay,
Okay.
congrats. So I want to talk about a few things. First thing I want to talk about is naming. So notice when you wrote the examples, like line 278, you have to keep scrolling up and
Yeah.
down. So you don't have to do this, but this is what I like to do. I like to name my examples more specific. For example, like this,
Okay.
or like one, two, three, like, give it a descriptive name, so
Yeah.
that you don't have to keep scrolling up and down. So like, no num list is okay. One num list, I would do like list 10, for example.
Oh, okay, okay. Yeah, it makes sense.
Uh, for future reference, it's going to be harder for like, for example, when you're making a graph. That's going to be harder, but you have to find
Yeah.
ways to make your life easier for yourself.
Okay.
So that's number one. First is have descriptive names for your examples to make your life as easy as possible. Next observation I want you to make is this is very important, okay? A recursive. Oh, do you know the word recursive?
Yeah.
Okay, self-referent. It means defined by itself, self-referential.
Yeah.
So a recursive data definition requires a recursive function. Okay?
Yeah, okay. It makes
Notice
sense.
how, so you remember, now you know why I did attention at the beginning. The key idea
Yeah.
is to realize that you had to call the function that you're currently writing, which leads to my
Mm,
third point. You can use a function before it has been defined. Okay?
okay.
It just needs to have a signature and purpose statement. So just now you're thinking, oh, I have the rest of the list. I need to sum the rest of the list. If only I had a function that can sum the rest of the list. Oh, sum list. That's the function I'm running right now. All right, you had that thought just now, right?
Yeah.
In order
Yeah.
for this to happen, you need two things. You need the purpose statement. You need to know what the function does. It's going to sum to this. Very good. Second, you need the signature. What does it take in? What does it produce? Takes in a list, produce a number. This is just the first two steps of the design recipe, right?
Yeah. Yeah. It is
Okay.
nice.
There may come a time not necessarily right now, but there will come a time where you may only complete certain portions of the design recipe and move on. Sometimes you only write the purpose statement and signature and you move on because you don't want to deal with the body yet, because you don't want to worry about it. We'll
Okay.
revisit this idea in the future. Okay. Yeah, I think that's about it for now. And yeah, I think that's all the observations I want to make note now. So I'm going to give you your next challenge. We are running out of time, so I'm going to give you. I don't know if you want homework, but I'm just going to give you like all the tasks that I'm going to ask you to do. And if you wish, you
Okay.
may work on them on your own time. If you don't have time, that's okay. We can go through them together.
Yeah, I have like plenty of time.
Yeah. Okay. Very good.
Like
You're
we have
spending your
like
time
holidays
productive.
in Poland. I don't know
Oh,
if you
it's a
have
summer break, is
guys.
it?
Yeah, yeah.
Check what the length of the list of numbers. I see. Okay. I'm basically on holiday right now because I'm job searching. That's why I also have time.
Oh, okay.
List contains the given number. Okay, can you work on task one first? Get the length of the list of
Mm,
numbers. I'm gonna write out
right,
the rest
right.
of the tasks. And you can just write it anywhere, like maybe below the tasks. Check whether a list doesn't contain the given number.
Yeah. Okay. Mm,
Wait a minute. Oops, sorry.
oh, sorry, sorry.
That I don't know why, but the Visual Studio Code teleported me.
Oh, I yeah, I frequently like switch the last two letters of length. Yeah, it's
Like that word specifically?
yeah, yeah.
Huh, that's interesting. Like, how about like breadth?
No,
Would
I wouldn't do that.
oh, okay, that's very interesting. Okay.
Yeah, yeah. It's like sounds to me like it would be like T at the end.
Interesting. Okay. Blanket.
Uh, okay, I can just copy the template.
You know, it's
Uh,
very good.
it would be not. Can call it.
Nice.
Yeah. Uh,
Descriptive.
okay. Uh, okay, it'd be like 0, and here it would be like 1 plus.
Oh, oh, you're done.
Yeah,
Oh,
is
you did
that
the
correct?
HT again.
Oh, yeah. Yeah, I
It's
was
very
worried
interesting.
about
It's so interesting.
that.
I've never seen this before. Okay. All right,
Yeah.
perfect. So notice how we didn't even use num at all. So we don't have to use all things in our template.
Right.
Yeah. Okay. All right, we are out of time. Good work today.
Okay.
I think you're definitely getting
I
to the more
might
interesting parts.
I might like book a lesson for tomorrow.
Oh yeah, oh yeah. So
So,
for this week, so yeah, my I got a
okay.
lot fewer sessions now, for you,
Oh,
And I think I'm gonna allow anyone to just do like at most once a day, cause
Oh,
like my
so
my
okay,
schedule's
okay,
empty. Yeah, so like at most once a day. That's the new rule now.
okay. Really? Okay.
Yeah, so
That's
it sounds too good to be true, right? I know that because like no
yeah,
one's booking
yeah.
sessions now. I have like 5 students right now that's like regulars.
Oh,
Yeah,
that's
so
like
you should be very happy about that.
yeah. I'm really happy. Yeah.
Okay.
So
All
like,
right.
thank you for today.
All right, no problem, dude. I'll see you tomorrow then.
See you
Okay,
tomorrow
bye-bye.
then. Bye.